Okay, this next section, 2.4, if you look in your book, is actually called Properties of Algebra. But we're also going to use this section to introduce a much bigger idea, and it's an idea that will come up pretty much for the rest of the first semester, and it is something that will come up a lot of places in just your life in general. It'll come up in your writing when you begin to write argumentative essays. It'll come up if you're ever just kind of debating in debates, if you're debating with people. It'll come up if you become a lawyer one day and you have to make a case against somebody. It comes up anytime you're making a rule or a statement. But more importantly, this is something that has to do with understanding the things that you believe. If I believe something, it's not just good enough for me to just believe it. I need to understand actually why I believe that. I need to be able to point to evidence as to why I feel like this is something that is so important that I'm going to say this is a belief that I have. This is something that I trust is true. So when we deal with truth, we're dealing with the ideas of making formal arguments. So what we're going to do is this section, this is actually we're going to do this section in 3 parts. So we're going to have 3 different videos. And this first part is all going to deal with just formal argument. First of all, defining what that is. What does that mean? How do we make a formal argument? Why does it matter? And then we're going to jump into how that pertains to math and geometry, because math and geometry is actually one of the easiest places to learn how to formally argue because the rules are so black and white. There are a lot of places in your life when truths that you hold are not just black and white. There's a lot of gray, so making a formal argument is a lot more difficult, whereas in math, the rules are very easy. It's black and white. So we're learning this to essentially be able to make formal arguments in math, but in a grander scheme of things, this has much bigger ramifications than just math. It has the ramifications of you understanding what you believe and why you believe it. So let's talk about what a formal argument is. An argument is trying to prove some truth. Okay, so I'm going to write that out. An argument to me is an attempt to prove a truth. If you're arguing with someone, you are trying to show them how and why what you are saying is true. Why what you're saying is true and maybe what they're saying is less true or not as true. So an argument is an attempt to prove a truth. And there's lots of ways that we can do this. Typically, it comes by a series of if-then statements. In other words, if this is true, then this must be true. And then if this is true, then that must be true, so on and so forth. We just keep going down a series of if-then statements until we get to the truth that we are trying to prove. Okay? And so we could do this with anything. Take any commonly held belief, and you can make the argument for why you believe that is true or why that is a truth by any series of if-then statements. And we're going to use the example problem that we did together in class a few weeks ago to prove this point, okay? And so you may remember this. If not, I'm going to try and paint the picture as clearly as possible, okay? And that was the hostage problem, if you remember it. So I'll just reintroduce it really quickly. Here was the idea. There were 4 hostages. They were taken hostage, and their captors went and they buried them up to their heads in the desert. Okay, and there were 4 of them, and so if this is the ground right here, all you could see out of the ground would be their 4 heads. They put 3 of them on one side of a brick wall, and they put the other guy on the other side of a brick wall. Okay, so here's our brick wall. Okay, there's our brick wall, and they face them all in the same direction. Okay, so they're all facing this direction. Even this guy, he's looking that way. And they can't turn around and see each other. They can't take their arms out and turn around or anything. All that they can see is what's directly in front of them. So this guy can only see the wall. This guy can see the guy in front of him and the wall. This guy can see both guys in front of him and the wall, but none of them can say this guy, and this guy's only looking this way. Okay, so that's the scenario. And the captors, the people who captured them, give them a problem, and they give them an opportunity to get out. And they say, okay, here's what we're going to do. We have two different colors of hats, and we have red hats and blue hats. Okay, so our red hats are going to look like this, and these little triangles, and our blue hats will look like this. And we're going to put two red hats on two of your heads, and we're going to put two blue hats on two of your heads. And what you have to do is, if any of you can say the color of the hat that is on your own head, you can go free. We'll set all of you free. Now, it doesn't have to be all four of them. Not all four of them have to say that. Just one of them. Only one of them has to say the color of the hat that is on their forehead, on their head. And if any one of them correctly guesses the color of the hat that's on their head, they all go free. But if they say anything that's not a color of a hat, or if they say a color of a hat that's incorrect on their head, then they will all be held captive for the rest of their lives. Okay? So this is the scenario that they paint, that these captors paint for these hostages. And I'm going to tell you at the start that there is a way for them to know in every scenario how to go free. That there is a scenario where in every scenario at least one person can know for certain the color of the hat on their own head. And I'm sure you remember this, but it's not that easy in this case. Here's why. There's not just one way that these captors could put these hats on their head. There are actually four different ways, and so we have to be able to have an argument, a formal argument for how someone could figure out the color of the hat on their head in every single case. Okay? So let's just put these hats on these hostages' heads and see if we can make an argument. Okay? So for example, let's go red, red, blue, blue. So let's say they put a red hat on this guy, a red hat on this guy, a blue hat on this guy, and a blue hat on this guy. You have to be able to make an argument for how one of them can know for certain how to go free. It's not quite so clear. We're actually going to come back to this example in a second because I'm going to show you a simpler example. Okay? What if they put two blue hats here and they put two red hats here and here? What would be the formal argument to say that one of them could know the color of the hat on their own heads? Well, we of course know, because we did this, that this guy right here, he could know the color of the hat on his own head. How? Well, if he's looking in front of them, he knows there's two red hats and two blue hats. If he sees two blue hats in front of him, he knows for certain that the color of the hat on his head must be red because there's only two blue hats. So if he sees the two blue hats, then the only thing that's left is the two red hats. So he would know, okay, the color of the hat on my head is red. And so he could say red. So that is the argument, right? We can say that argument out loud, but how would I make that formal argument if I was actually writing it out? How could I make the formal argument if I were to write it out? And so we're actually going to do that now. I'm going to do that now. Here is an example of the formal argument. You always start a formal argument with the things that you know for certain are true. What is the given information that you know for certain is true? The only given information here that they know for certain is true in this case is that there are two blue hats and two red hats. So we start there. That's the beginning of our argument. And I'm going to make this font a little smaller. I won't make it quite that small. There are two red hats and two blue hats. And then our argument would be to say this. If the hostage in the back sees two blue hats in front of him, then what? Then he knows for certain the color of the hat on his head must be red. Okay? That's the formal argument right there. Two sentences. There are two blue hats and two red hats. If the hostage in the back sees two blue hats in front of him, then he knows for certain the color of the hat on his head must be red. We've covered one of the four cases. Okay? Now, if this was the only case, then we'd be done. But that's not the only case. And I think you can see where we're going. There's another case that would be very similar to this that would allow us to make the exact same argument. And that is, of course, if the red hats were right here, and I'm going to try and cover up the blue hats. If we had two red hats right here, and the blue hats were right here, the argument would be the exact same. Do you see how the case is different, the scenario is different, but the argument is the exact same? So we can come down here and continue our argument with this second case. Okay, where we say, okay, if the hostage in the back sees two red hats in front of him, then he knows for certain that the color of the hat on his head must be blue. Okay, so it's the same argument, different scenario. You don't necessarily need to be writing all of this down, but I really want you following with me so that you're understanding this point that I'm making about formal arguments. Now, there are a couple of cases that we haven't dealt with yet that we'd also have to make. Okay, and once again, it's the same as our example here where the scenarios are different, but the argument for them would be the same, and that is this. What if these two hats in the middle aren't the same color? For example, what if this is red and this is blue, where this guy would not be able to say for certain what the color of the hat on his head is? And it doesn't actually matter how we combine the other two hats. And if you remember, here is the argument for this one. In this case, this guy can know the color of the hat that's on his head, and here's why. Because he doesn't hear this guy say anything. If this guy doesn't say anything, then we know both of these cases right here can't be the case. If he doesn't say anything, he has to see this guy in the back. The only way he would not say anything is if he sees two different colors, right? Again, like we said, if he saw two blue, he would say something. He would say red. If he saw two red, he would say blue. So if he doesn't say anything, then these two guys must have different color hats. So then this guy right here, all he has to know is, okay, because this guy right here isn't saying anything, then I must have a different color hat than the guy in front of me. So the color of my hat must be the opposite color of the color on the hat that I see in front of him. So the color on my hat must be blue. So that is the argument. How can we write that formally? Okay, so remember, we have to cover every case in order to make sure that this is true. The argument would look something like this. If the hostage in the back sees two different colors, then he won't say anything. If he doesn't say anything, then the third hostage, upon hearing silence, knows that he must have a different color hat on his head than the person in front of him. So he can know the color of the hat on his head is the opposite of the color on the hat of the hostage in front of him. And that is the argument. And notice, if you go back and read through this argument, this would also work for the opposite case. Let's say these were switched. That exact argument would still work. And I think you guys will see that if this was blue and this was red, then this argument would be the same. If he doesn't hear him say anything, this guy right here has to know that these two are wearing different colors, and he can know the color of the hat on his head but just by saying the opposite of whatever color's on his head. Okay? And we've covered every case. You can combine these hats any way that you want, and the only cases we need to cover are if there are, two blue or two red, or if they have opposite colors. So it's not good enough just to be able to guess the answer, especially in this case where the stakes are high. These guys were going to be prisoners for the rest of their lives if they didn't get this right. If you can formally argue this, you can make a rule about this. You can make a truth, and we have made a truth. This is the formal argument behind these guys knowing how they could be set free. So this was a silly example, but I wanted to make the point of that sometimes it's not good enough just to argue. You actually have to be able to formulate that argument into an actual plan, something that you can actually write down and represent as an argument. And it's written as a series of if-then statements. They might not always necessarily say if and then, but you can go through and read all of these statements are if-then statements. And we've proved a truth, and that's that in every single case, they can always go free because someone will know the color of the hat on their head. It'll either be this guy or this guy. Okay? So with this idea of formal arguments in your head, we are going to introduce some rules in algebra, some properties of algebra that will help us make some formal math arguments. And then we will come back on the backside and we will do some math that you've done for a while now, but we will actually look at writing the explicit argument behind what you are doing. It won't just be doing the math anymore. It'll be also arguing why you can do that math. Okay? So I hope you enjoyed this video. I hope you understand what a formal argument is a little bit more. Watch the next video will just be introducing the properties of algebra, and then the third video will be examples of using that property of algebra.